welcome to our video today. This is at the request of one of our subscribers, so I might just add thank you. It actually helped us a lot. As in all cases, any shared designs, remedies, and whatever are intended to show you what we've done for a complete repair. And if you're not qualified or don't know how to do these things, you have to exercise all safety and get somebody qualified to do them for you. But hopefully after you watch the video, at least you'll see what it takes to do a proper analysis of repair. This is a kiln tune-up, so this kiln's working. It's been working over the holidays hard, and we finally found some time to do a checkup on it. So here's our little kiln tune-up video, and let's run it right now, and we'll close it out with just a couple words. Right, today we're going to do a full checkup on this cone art. It's a 3-zone kiln. We did have it in the video on changing this top thermocouple, and as you can see, that's fairly new. First thing we're going to do is visually inspect this kiln and look at those bottom guys, and I don't see any minor cracks. The minute we see them, then we'll replace those. So now, what are we going to do today? Well, first thing is visual. Actually, first thing is unplug the power. Next thing is to open this kiln and so open the kiln, and the next thing we're going to do is go through and make sure nothing is loose. So I'm going to visually examine each wire, make sure it's tight, tug on it nicely, nothing is loose. Make sure don't see any burn marks or obvious burn marks. And again, I'm going to go through every single one. And I'm even going to look at the mains and make sure they don't look burnt and they look all tight. And then the relays, we're going to make sure all these connections are tight. They're pushed on securely. Again, no burned ends. I'm going to do every single one, as on occasion, when you replace a relay, we may accidentally not put it on all the way. Here's the transformer. So every connection is tight. So everything looks in good order from a visual exam. And now what we're going to do is set up. And if you can see on the mark, I've marked 12 ohms. And most of the kiln manufacturers will tell you what the resistance rating their elements are. So if you have that, that's 12 ohms. And that's 11.7. So next thing we're going to do is set up and measure the resistance of these. So stand by and we'll do that in a minute. All right, we're back. First step for a full checkup is check our element resistance. Do that again. We're going to measure the top set of elements, which are here. And so I'm going to back probe both of these. And I get 12.3 ohms measured. I have a 12 ohm marker there, so that's in pretty good order. My next set is here. And I will just read it to you. I'm going to back probe this connector. And this again is 12 ohms. And I've got 12 ohms written on there. And finally, I'm going to do my third set of elements. And I'm going to back probe those. And I get 11.9, 11.8. And that's marked as 11.7. So all in pretty good order. I'm pretty happy with those numbers. Next step, I'm going to do a power on test and measure the amperage. So stand by for that. Okay, we're back. We found our clamp type amperage meter where we clamp it around the wires, and I'm going to set the scale. In this case, 40 amp scale is plenty, and I'm going to go ahead and check each circuit of elements. So this is the third one, the second one, first one, or top, middle, bottom, however you want to look at it. So if I look at the top two elements, I get 16.1 amps. If I look at the middle elements, I get 16.4 amps. And the bottom element, I get just 17 amps. So I like all those numbers. They're within range for this machine. There's nothing out of the ordinary. So I'd be pretty happy with that. We're going to go a step further. We're going to let this run until it reaches a few hundred degrees, and these relays have been running. So one of the questions is, how do we check these relays? Well, if one of these relays was bad, we would get no reading. So let's say the top relay was bad, we'd put our amp probe here, we'd get nothing. So then we would suspect either an open element or a bad relay, and if we had already measured the resistance on our elements, we'd know it's not open because we got 12 ohms like we're supposed to. So then it would be the relay. But now we're going to do a little bit more. We're going to take a temperature non-contact thermometer, and we're going to measure the temperature of the relays, and it's a nice predictive way to tell if your relay's good, bad, or going bad. So stand by and I'll get some devices to measure that with. So I got some temperature devices. This is the coolest one, and if I look, I've got 109, 109, 113-ish, 110 maybe. So they're all operating the same temperature. That's a plus. As long as I've got this machine with me, I'm going to look around for any super hot spots, and that's kind of warm, but it's only 85 degrees nearby. So that's the end of an element. And as I look at all these, they look pretty good. The one in this very bottom left-hand corner, it looks like I'm going to tighten up once I pull the power off, because it's considerably hotter than the rest. So if you have one of these, that's great. If you don't have one of these, then you can have a cheap one of these, and you'll get about the same results: 96, 103, 95. Now, if you watched the previous video, you know this relay was 227 degrees. So that's crazy hot comparatively, and we knew that relay was going bad. So now we're going to try to get some advantageous point so you can watch. So again, nothing really crazy hot like 200 degrees. That connector down there, though, if I could hold this steady and stay behind the camera, doesn't look too bad. I got 140-ish out of it. So again, that's one we're going to check. The rest of these look good on the floor, and as I scan through them, they're pretty decent. 80, 90 degrees. So this bottom corner one is 130, 140. I'm going to guess that that is loose and corroded a little bit. So it's hotter than the rest. This isn't the greatest device, but it's very economical. And I'll probably go through the rest of the machine just looking for really hot spots. And this is kind of a super way to go diagnose this machine. So we found one. This is a full checkup. So we did our visual. We went and checked all of our connections visually, and we tugged on them all. They're all tight. And now we're going to shut the machine off because we know this is hot down there, and we're gonna pull that apart, take a look at it, and probably clean it up and put it all back together nice and tight. So stand by for that. All right, we are back again, and after closer examination, we found these two connectors. I don't know if I can get these to focus real well. They're pretty burned. They're much darker and corroded. And so that was one of our bad connectors. So we replaced this wire, and both connectors are nice new shiny copper. Tighten them down a whole bunch. We trimmed this wire back because this is what we found on the ends of our wires. They're quite burned, corroded, and brittle. So now we took this piece out, got a nice new piece of MG wire, which is rated at 450 degrees C, which is more probably the hottest wire you can buy. I keep a supply of it just for this, and we will fire this all up again and double check that connection. But it's a good thing we did a nice full thorough checkup, because that connection was wasting power heating up and probably going to damage our relays as well. So back in a second, we'll do some temperature measurements just to make sure we're done. Okay, back again, and no longer are those guys the hottest spot in the kiln. And as I go through, not too bad, but these are the ones we fixed, and no longer are they 1,000,000 degrees. So nice work. We'll double check it with the other handheld, the non-contact economy mode, and this time I'm going to kind of get in the picture so I can actually check it with us. And here we go. So 76, 77, way better. So good thing we did a thorough checkup. We would have never found that. And again, we're going to throw away these burned connectors, and we're throwing away this wire that's burned. And next thing we're going to do is turn the power off, close the kiln up, and then just go through how to set up the Bartlett controller, which is quite popular. It's on a lot of kilns, to see what's going on in the kiln and give you some insight. And then again, what we do here is print the error code page out of Appendix B for Bartlett, and I even went and printed the one-touch information hotkeys, and we have it here so that if at any time anybody's here, they can go look these up. And we'll show you how those work, and be back in a minute. Alrighty, we're back. Everything's buttoned up, power's reapplied, and we're gonna do a focus on me here, please. A full power test. And so we're just going to follow the instructions. This full power test, program a 1 segment program to go to, and they say 1,000. I'm going to go to 500. No hold, 1 segment. Go as fast as you can. So single user 1 segment. The rate is fast as it can go, and 500 degrees. My last program is still in there. No hold, and again, I'm complete. So this is a Bartlett controller. It's real common on a lot of kilns, even though they're rebranded under L&L and all kinds of things. So start, and this is going to turn all the relays on and keep them on until 500 degrees. So how do we know all the relays at least are trying to be turned on? Well, I downloaded the technical manual as well, and I don't know if you can read this, but if I hit 8, 3 dots will show up. Those 3 dots mean relay 1 is on, relay 2 is on, relay 3 is on. And since we're trying to go as fast as we can, that's exactly what we expect. If I hit 8 again, it turns those off. So at any time this kiln is running, I can see which relays are trying to turn on. So it helps from a diagnosis standpoint. 0 always shows the elapsed time. In this case, it's virtually no time gone by. And 5 gives me the rate of rise in the last 22 minutes. Unfortunately, I have a program for as fast as you can go, so we're not going to get a number. So that's a little about this. These are handy things to have on site. All the errors are here, and a lot of times the errors will tell you exactly what went wrong, so it's really good to have this page ready for yourself, and this works great in the studio here. So pretty simple stuff. If you're not familiar with doing this, then we don't advocate that you instantly get an experience. You can call your kiln tech. But as far as the diagnostics goes, you might get an idea with the infrared, especially the heat gun, which is not too expensive. The visual inspection is obviously real important. Anyway, that's a soup to nuts tune-up for this kiln, just to make sure that it's going to keep operating well. Well, thanks for watching. Hopefully it turned out to be an informative video. We tried to show a little of everything on a tune-up, and thanks again for that subscriber who requested this. We would have not found that defect as soon as we did. Anytime you see any burned wires, charred or burned or annealed, then generally the wire is not so good at that point. It's corroded. It's going to be a problem. The connection is going to continue to heat and consume energy. So, thanks for joining. Hopefully you found it interesting, and we'll see you in the next video.